Okay, for people joining us on the live stream, we are reviewing some geometric computing capabilities for the upcoming version of Wolfram Language. All right, so we had already looked at a bunch of things with polygons, right? And polygons with holes and so on.
That's right.
And did we confirm, wait a minute, what is this outer polygon? Did I look at that?
So the canonical form is given as an outer boundary with any number of inner boundaries.
Okay.
And however you construct it, canonical polygon will generate that form.
So if I were to take this polygon P here, and I were to say, for example, oops, I don't know what that did, sorry. And I were to say, by the way, I noticed that there are no predictive interface things here, which is kind of a shame. Be nice if that was possible.
Okay, I'll report that.
Is that what is the right
region difference?
Okay, so if I say region difference of P, comma, and then let's say I say triangle, is it just triangle or triangle SSS? How do I make a triangle with 3 points?
Just triangle.
Okay, so if I say 0.2, 0.3, 0.5, 0.5, 0.7, 0.8. Okay, now I say graphics of that. Oh, very swank. Okay, now if this had completely opened this thing, what would have happened?
Say that again.
If this had completely sliced through that polygon, what would have happened?
Even our old polygon could have multiple polygons, which are effectively unions.
I see. So that would just become, would that just become a list there as opposed to, I mean, if I look at the internal...
the polygon itself has multi-polygon inside as a version 6.
Okay, so if I look at that, okay, I don't understand that. What did that just do? So I see that had, because it wasn't a hole, it didn't have to use...
Right.
It just, well, that's nice. So it canonicalized it to not using the hole.
Yes.
Okay, so if I pull that in there, I don't even know where it is, but that's presumably that one there. If I say 0.6 there, I need to pull that in as well. 0.6 to there. Okay, now it's holy, so to speak.
Yes.
Okay, so now if I say input form of that, oh, very interesting.
Right, so we will update this normally, before we are returning boundary mesh, since we didn't yet have a polygon with holes. So we'll update the code and return a polygon with holes.
Why didn't that work?
We're still writing it. It's not yet fully done.
Okay.
It will work.
Okay.
So there's a lot of little things like that to complete. Well, not a lot, but there is, it's a big system.
Right. But so, okay. So then, have I seen outer polygon and inner polygon before?
Yes, last time.
Okay. All right, fine. Okay.
These are utility functions, Stephen. These are all of these polygon coordinates, outer polygon, inner polygon. They're utility functions.
So when polygon coordinates, what does that do? I mean,
it gives you the coordinates. So if you have self-intersecting curves, it will compute the intersection point. It will give you exactly the coordinates used for that outer inner representation.
So in other words, if I say list plot, or if I say graphics of point of this here, that will be all of the, oops, what the heck happened there? That's nasty. That was a nasty selection problem. Okay, so what is that? Those are the, I see, those are the points, those are the inner points as well as, right, so those are the corners.
Yes.
Should it really be called well, let's see. I mean, is polygon coordinates really the right name for that thing, which is really polygon
We call it mesh coordinates for meshes. I think polygon coordinates would be the analog. You know, if we're building out a little subsystem for polygons and polyhedra.
But does it not bother you that the polygon coordinates include random things that are the holy parts of the polygons?
No, it should. It should.
Okay.
No, so the point is then that the rest of it is just a connectivity structure. It's just a topology. It's the correct.
I see. So that's like a graphics complex having
exactly like a graphics complex.
Okay. Okay. Have we looked at these yet?
Yes, we spent time. So crossing and winding polygon, you should look at them. Those are the two constructions. Remember, I did a presentation last time where we talked about sort of what defines a polygon, what defines sort of what points are in a polygon. So crossing and winding give you a little bit richer set of constructors. They return polygons. Now, a different way is random.
Sorry, what was that? What is that input thing there?
That's two closed curves that are. That's a particularly complicated example because it has both.
Oh, that's an iconize.
Yes, that's correct. Just to show this.
I've not seen an iconize that looked like that yet. That's rather swank. Wait. How did that know to iconize itself as?
We did that manually. Iconize of the list and then copy.
I see. Okay, because that's the usual iconize.
Yes.
Okay. Okay. Fine.
So you see, that's a particularly complicated example, right? Because there are two closed curves. Both of them are non-simple curves. They intersect themselves.
Yes.
And the membership is computed on both of those together for crossing polygon, as we talked about last time.
Right, I remember that. But so let's see so in practice, who's going to use crossing polygon?
It gives a case because we support multi-polygons. We hadn't done the general case. This one allows you to do that general case when you have multiple closed curves, because we interpret multiple closed curves as union in multi-polygon.
Mm-hmm.
Okay, so this is, you know, and the things that are conventions in different file formats for what definition of polygon is used.
Yeah. Okay.
Okay, and in different systems, and we wanted to provide all the constructors that you could wish for.
Okay. Well, there are probably a bunch of cool demonstrations that can be made with. I mean, you know, you can get all kinds of cool effects with this.
Sure.
Don't forget, you should reference opacity from here and things like that. Does that make sense? Because people who are, you know, what this is about is what happens when polygons kind of, you know, are on top of each other and so on. Is that fair?
Opacity sounds a little weird, but can do it.
I would reference these things I would reference these things that are about, you know, how things go on top of each other.
Okay.
Because like in that case, right, this is kind of like a weird negative opacity type thing in some sense for visualization purposes.
I see, yes.
Okay. All right, so this, let me just take a look here. Crossing count. So how general is that? I mean, can you also do a crossing count of a region?
No. It's for polygons and polyhedra.
But in principle, in the future.
In principle, yes, but in practice, no.
Yet. I mean, but one day that would be an interesting thing to have.
Yes, but we're not there. So we shouldn't document it.
Number of times you wind around point when sweeping the boundary.
Well, that's what I described with the angle criteria last time.
Yes.
I think that the most interesting, I mean, you should look at those pages when you want, but random polygon is really useful. So these are classes, and we can add more in the future. these are important classes. Convex and star-shaped is also known as star-convex. And simple, a simple
random polygon of no arguments do something useful.
Well, that was just something we added for our own testing. Normally, you should, we just pick a point between 3 and 15.
Well, 3 is the minimum, right?
Right.
Do you want to document that? It seems very weird. Okay. By the way, if you want that to not show up.
Yes, we need to add a pattern.
Yeah. It seems weird, but I guess what the heck. So, okay, so if you say graphics of this is nice, I agree. This is useful. Why do you say star-shaped as opposed to star here, given that you've got convex, simple, I mean...
Star, I mean, as always with things, there are multiple names for the same things in the world. And star-shaped is one, star-convex is another for it.
But maybe you just call it a star polygon. I mean, I don't even understand what this is doing now. Why doesn't it, what's...
So star means that it's star-convex. It means that there is an open region in the middle from which you can see where you have a straight ray to every point in the polygon. If it's convex, then from every point in the polygon, you can see every point in the polygon. There's a straight line within the polygon that goes to that point.
Oh yeah, this is interesting. Well, I see. Are you recentering it to a particular centroid or what?
No, by default, it's sample in the unit box 0101. So when you give the data range, then we adjust it.
Okay. But you're not centering the centroid.
No, it's not.
I mean, another argument would be to put the centroid on 0, 0. What does regular polygon do? It puts the center at 0, 0, doesn't it?
Yes.
By the way, why does regular polygon not produce one of these polygon thingy dingies? Should.
At the time, because wanted to be able to give formulas and whatnot for it. If you have regular polygon of n.
Fair enough. Okay. All right. Fine.
But canonical polygon will do that. If you want a polygon.
Okay. Beautiful. Okay. So, but regular polygon, if I'm not mistaken, if I ask for example, centroid, why doesn't that work?
Region centroid.
Yeah. Sandra on our live stream is agreeing with me that the coordinates for a random polygon should center around 0. Can you explain why that's not a good idea?
No, it's pretty arbitrary. I think that they could center around 0. They could be in the -1 to 1 box or something like that.
I think that would be a good idea.
But I don't think that the centroid needs to be at the center. That seems
no, fair enough. That I agree with you. That probably doesn't need to be there. But I think -1 to 1 probably makes more sense. Oh yeah, actually, Sandra is making the amusing point that if you put it in that, if you center it at 0, 0, you could use it as a plot marker.
It's trivial to do whatever you want with it if you want to translate.
How do you center it to 0, 0?
You just translate polygon and then minus region centroid of the same polygon.
So what I would say translate that polygon minus...
No, comma.
Yeah, but obviously I've got to do it with the hash sign because it's a random polygon there.
Right.
Okay, but the thing that's much more exciting that I'm about to see is I want to jump to 3D, where apparently you don't have... So if I say 1,3 here, so now if I say graphics 3D of that, oh no, that's not what it's going to do. It's going to do, I see, it's a polygon in 3D as opposed to a polyhedron. Do we have random polyhedron?
Yes. Although
it's not yet working, we are working on it.
It will work.
Okay.
So these polygons, by the way, can live in any dimension. 3 is not the limit.
No,
If
I
you want
understand.
to live in 10D, it's fine.
Something went wrong with that. Oh, I must have done that. I will fix that. Method. What are the method options here?
I think that that's just filled in right now and not.
Right, but people have different ways to sample it. So that was the whole idea in case people have some specific method they want to use.
Okay, hold on.
One thing that's hard about these things, Stephen, is that so here's where I think it will evolve. The good way, the hard thing is to characterize the distribution over the space of all polygons or space of all polyhedra, and that their sampling scheme will uniformly fill up that space in some sense.
Yes. Hey, wait a minute. Why is there an inconsistency between the way that you're specifying these properties like simple and convex here? I don't think this is right.
No, you're correct. We haven't finished the random polyhedron page. And actually, the specification should be based on the face, not on the point. So it's...
Yes, both of them needs to be based on face. So that means that they're then consistent. So the corresponding thing to face for polygon is edge. It happens to be the same number as vertices.
Sorry, I don't understand. The edges...
So for
polygon, it's the same number.
For polygon, it's the same number, but if the language is going to stay consistent, it should be, say, edge instead of vertex.
But in general, wouldn't you want it to be the case that for a polyhedron, that you would be able to independently specify the number of faces and edges in a random polyhedron?
I don't think so.
Why not? I mean, that's a degree of freedom, isn't it?
No. I'm not entirely sure, but I don't think so.
Well, I mean, yes, but the whole problem is also, to be able to sample them based on on those parameters you're providing, which is in most of the case impossible.
So wait a second. I mean, but yeah, by the way, responding to Sandra on the live stream, random polygon does have an option for the bounding box. That's what data range is.
Yes.
Right. But I'm sorry, I don't understand. Why isn't it an independent parameter, right? I mean, you've got Euler's formula for which connects the 3 of edges, faces, but
you're correct, okay? But here we have a certain other geometric property that's not only topology, and I'm not saying it's impossible. We don't know how.
Okay. To make a random polyhedron, you're saying to make a random polyhedron with X number of vertices, and because you can pick the vertices. Is it the case that you can pick the vertices kind of at random, right, in 3D space, and then you just join the polyhedron? Is it the case that given a set of vertices that there must be multiple polyhedra that join those vertices?
Yeah, many.
Right, of which some are simple, some are convex, etc.
Right.
And my point would be that you should, just like with a graph, I mean, it's not self-evident.
So here's what I think we need to do, okay? We need to have basically a random mechanism which we can then prove that asymptotically provides uniform sampling in the space that we're describing as you're sampling it.
Right.
Okay? I'm not sure we've reached that for polygon, but I'm not sure we're going to reach that for polyhedron in the first iteration.
Fair enough. It's not totally obvious how that would work.
Exactly. It is not totally obvious.
Okay.
So, and if you look at the page, I think in the application of random polygon, we kind of try to explain the distribution of that case, I think.
In the application section?
Yep. I did tentative. I think probably basic use.
Geometry probability?
Yeah, geometry probability.
Under applications. Open a subsection.
I see. So that's a convex polyhedron. That's interesting. I didn't know that for sure. Has a Gaussian distribution of areas. Is that what you're saying there?
Right. So, I mean, from from the data, and theoretically also there is proof of convergence, the asymptotic of the shape.
Okay. Well, fascinating. All right. So, okay. So random polyhedra is still a bit up in the air.
Yes.
Okay. Polygon decomposition.
So that takes a complicated polygon and breaks it down into a union of simpler ones, like convex ones.
And it should be called polygon decomposition as opposed to polygon decompose.
Well, we call everything else decomposition, you know, Hermite decomposition, Jordan decomposition.
Yeah. All right. Seems okay. I see. And the default, do you have to give a second argument that says what kind of decomposition to give?
No, the default should be just sample, I believe.
Yes. By the way, Sandra on our live stream is complaining that data range is unusual in its use in random polygon. Can you comment on that? That is, that's not the standard use.
It's primarily used for plot functions, but data range has.
By the way, is Sushma here? There's obviously something horribly wrong with the speed of the autocomplete here.
Mm-hmm. Yeah, I see that.
And there's something horribly wrong with the autocomplete itself.
Data range was introduced originally for viz functions.
Right. What range of actual coordinates the data should be assumed to occupy?
Yes.
Range. Yeah, that's okay. That's not unreasonable here. That's not an unreasonable thing. So I mean, but how does random polygon? Well, I'm sorry. How does regular polygon work with this? Oh my God, this is ridiculously slow.
It doesn't have an option. You just have the center to shift it, translate it.
Well, we have a radius there. Yes. So ultimately we're doing that. And so now for random polygon, by the way, are you sure you want the dimension to be the third argument?
I think we discussed that last time, and you said you wanted a rule or something.
Right. D goes to spec.
Yeah, that would be nicer. Is there a problem with that?
No.
No, I think that's fine. It's actually kind of nicer in a way, because then spec is held together more consistently.
Yeah, I think so. Should we support higher dimensional polygons in regular polygon? Why not? I mean, they're just going to go on the.
But then we need, you know, in that case, what we need
Euler angles or something.
Well, I mean, Euler angle is one out of a zillion ways to specify it.
Yeah, right.
Just.
But I mean, the point would be this question about taking a polygon and embedding it in 3D. We don't have a convenient function.
We will provide that, okay? Because that's how implementationally, that's how everything works, both ways. It takes something in higher D, project it down, does it planar, and embeds back.
I see.
So, you know, we will, I mean, not for 12, but we will design those that we have convenient such functionality.
All right, fine. Fine. Yeah, okay. All right, let's continue here. On our live stream, Seth Chandra is asking, don't suppose you could have a random tiling of a polygon?
A random tiling? We're not doing tilings right now.
That's effectively a Voronoi.
No, Voronoi is one particular type of tiling. It's not a random tiling. It's just a very particular one.
Seth wants to create random political districts.
I see. Okay. Well, Seth, if you're going to be here at the conference, we should talk about that, because we have many things kind of brewing there. We'll be keen to hear more from you.
Is there Polygon simplification for version 12? A polygon that resembles the original polygon but has fewer?
No, but there will be.
So by the way, that particular thing like for map making. You know, we had this huge project.
I know. So you had special constraints there. There are various kinds of constraints that you want to go into polygon simplification. One is what's called topological simplification, meaning that you don't get new islands or self-crossings when you simplify and remove points. If you just use a simple signal processing, kind of low-pass filtering type of algorithm, that's what you'll get. You get weird topology. In the case that you did for geography, you also want them to be consistent. So if you simplify one side of it, that the country next to it has a consistent kind of simplification.
I don't know why we wouldn't want to consumerize what was done there. There was a lot of work put into that, and it was quite non-trivial.
I thought it was mostly manual.
No, not at all. There was a lot of code written for that, and there were some fancy algorithms that we used. You should contact Johan about that. See if you can just get that piece of code, and then give it a list of polygons, and you should be able to say simplify all.
But we need something very production grade. I mean, we're going to use this a lot. We're going to have not only polygon simplification, but we're going to have mesh simplification. We're going to have a lot of this kind of.
All right. Well, I you know, this was a significant project.
We'll get it.
It also has been used consistently for the administrative divisions of the world.
We will get it.
Years, right?
Okay.
And that presents many weird problems, these administrative division things.
And that's very useful to get that experience from what the weird problems are.
Right.
The signatures of problems.
Right. Okay. Region integration.
Yeah, so these polygons obviously are fully integrated with a whole region framework.
So you're telling me that if I say of this polygon, if I say this is amazing.
Well, that's a graphic. Okay.
All right. Okay. So if I take a random polygon here, and I say integrate x squared plus y squared, x, y, an element of, is this going to work?
Yeah.
Well, not in this version.
Well, it will work in the 12 version that we ship.
By the way, that's an interesting case. That is an interesting thing. We should have a smaller version of those.
It did, you know, for the old polygons, it did, right? It's just that that's what it takes when we do these very fundamental changes. And this has been massive on the front end side too. You know, so.
And it is supported in the cloud, right? With their cloud rendering and things, right? That is supported, isn't it?
Not sure about.
Oh, for God's sake, don't tell me somebody forgot that. We got to make sure that your polygons don't fail in the cloud, right? That's very cool, by the way, that worked. Okay, several very, very major points here. Okay, so Sushma, go chase the cloud people immediately and make sure that these, because they don't yet have a version 12 running in the cloud, and they were not aware, I think, of something as major as this that could go wrong.
Yes, I can check that. But is this in the master branch? Because I think they're checking the master branch.
It will be soon after this when we're done with the reviews.
Okay, yeah.
Okay, second issue. Minor point, but we should probably have a version of summary boxes that goes to a smaller size when it's in a subscript position. I've never seen one in a subscript position before, but it looks kind of silly. Does that make sense? Sushma, that's something for, I guess, Itai.
Mm-hmm.
Okay, take a screenshot of that.
Yeah, can we use iconize at that point? Something like iconize, I mean?
Well, yes, but I don't think we would want to use iconize as such. It's an interesting idea. It's an interesting idea to do that, to do auto-iconization of something where it gets too insane a subscript. But I think it's a simple thing here. It's like images that will get smaller, get smaller on a list and so on.
Okay.
Okay, well, that's very impressive that all of that works. Okay. Let's keep going down here. Polyhedron. Okay, so did we look at this already at all or not?
We did a first look, but you can sort of just follow it from top to bottom and you'll see that everything lines up exactly the same way.
Okay, so wait a minute. So if I say polyhedron of dodecahedron, for example.
Uniform polyhedron.
Uniform.
Why doesn't that work?
Well, because is the object is,
Okay, but what happens if I say, I don't see why we wouldn't make that work, just as a courtesy.
It's like saying graph of Peterson graph in his stream work. It seems slightly odd.
All right, fair enough. Okay, so if I do this, for example, boy, this is a mess, isn't it? Because this is returning graphics, right?
Yes, but there will be another return form that you can request.
But
and then the question is what the default is.
Yeah, well, I think maybe we could survive, maybe, if polyhedron data by default produces something which at least has some visual appearance, it might be okay, even without it just being a pure graphic. But how would I get your kind of polyhedron in as one of these guys as your kind of polyhedron?
So right now, is it hooked up, Charles?
Yeah, let's try. Maybe we cover this one. If you do also uniform polyhedron of the rhomboic.
Well, but also polyhedron data. Polyhedron data is more of a little bit more random collection of things.
No, not yet supported.
Okay. But what makes something, I mean, I don't know, in polyhedron data, I understand there's an infinite number of polyhedra and we've just picked particular named ones.
Right. You know, so, I mean, the particular class of uniform, you know, there are 24 of them in polyhedron data. There are 72 or 75 total that we want to get.
Which we will backfill into polyhedron data, presumably.
Yes.
When we have them.
Yes.
But is the rhombic hexagonahedron one of those?
Yes, it is. I mean, from the picture, it's a uniform one.
Okay. Okay, fine.
I mean, there's the possibility of returning a region out of, if you do region of that polyhedron, you will return something which rounded graphically. So, I'm sorry, from the uniform. Wait. That one.
Could do that too, yes.
Yep.
But you didn't do what Charles said, but that works too.
Okay, comma region here.
If you wrap region around it.
I see.
Okay, one that has, yeah, that one.
Okay. By the way, is the graphics fix that's making tighter bounding spheres working? Anybody know when that's coming in?
No, I've seen a branch from Yusu, but I don't know yet.
Okay.
I can't.
All right, but hopefully that will work for regions as well as for other things. It will automatically work for regions. Is that true? You don't have to do anything different to make it work for regions as it works for 3D graphics.
I think that what that does is supply that you can give an argument as a bounding sphere or bounding ball.
No, but I think the default.
Then the different functions need to actually use that. So it won't just automatically work.
Okay, so.
Okay, and then you have to actually compute that ball.
No, but I thought that the default for 3D graphic, well, okay, so that needs to be checked into.
So you understand, it can deal with points. Okay, so from points, we can easily compute a bounding sphere, the minimal volume bounding ball.
Yeah, the min ball thing.
The min ball, okay? In general, it's very hard to know, and there aren't always, we have infinite objects, so there aren't always bounding.
How do I get the min ball of this thing?
Region bounds.
And then that thing, min ball?
Oh, bounding region, sorry, bounding region. Oh. Region bounds is the simple one, bounding region.
I mean, you should use the mesh one. This will not work yet.
Okay, that's another minor thing.
Right.
Okay.
So there are long lists that we do to update the framework.
Yeah, I understand.
To support new objects.
I know it's complicated. Okay. Anyway, that's just another one. Okay, let's keep going here. Okay, so for example, if I say canonical polyhedron of this guy, well, how do I get that guy to be a polyhedron in your sense? Can I just say polyhedron of that thing?
No, number should try canonical polyhedron.
But I don't understand why polyhedron doesn't just work.
No, we can support that too there.
I think so. Okay, so now if I say what was I going to do here? I was going to say, I don't know what I was going to do here. If I want to know the number of faces of this polyhedron, what do I do?
But we don't have a function for that. Maybe that should be one new
I
function.
think we should. Yeah, polyhedron faces, polyhedron vertices.
Okay, we have to be careful because there's a lot of them. And we have the complete thing for meshes, and it's going to be...
But that's just for elementary usage. I mean, how do I compute the number of edges of a polygon? Or the number of vertices of a polygon?
Okay, so we made them all work with the corresponding mesh functions, in which case you have it, right? Charles, that's what we agreed on. We have that complete set of properties for meshes. You know, so you can get mesh count, you know, and then you say, you know, mesh comma 2, or sort of comma 1 would be edges, you know, the dimension 1 elements.
But I think we should provide, just like we provide area and volume and things, we should provide those things.
Okay, then we'll design a whole set of functions there.
I think so. Yeah, I mean,
they'll be slightly parallel. Okay, there will be parallel.
Fine. That's fine. There's a general mesh function makes perfect sense to me.
Mm-hmm.
So now, if I say outer polyhedron of this, that will still show the same thing, right?
It better, because this one has no voids.
Yeah, Sandra on a live stream is just pointing out that subfaces should work for a polyhedron. Does it?
What?
If I go to say this subfaces, I would kind of expect it to work.
I'm not a key fan of those subvalues.
Well, but we use them a lot. I mean, I think we need
Should we introduce them for point, line, polygon, polyhedron, for all graphic primitive?
No, it's kind of silly. We should have a discussion about that, but that's not where we should go primarily. Let's please, we don't have time, or it's not for obviously for version 12. So, but let's talk about that in the future.
Yes.
Okay.
But
for the time being,
we know what they are. We'll design a kit.
Okay, predicates. Polyhedron decomposition, okay. So polyhedron, does it only work in 3D or does it work?
It works in NAD. Greater than 3.
Greater than or equal to 3?
Yes.
Okay, delete duplicates, supports a tolerance option. Good, fine. Okay. Oh boy, angles.
Okay, so that's a new topic now.
Yes.
Okay, so you see the analog between polygon and polyhedron, right?
Yep.
Okay. Now it's a new topic, which is angles.
Okay. Interesting. Nothing is ever simple. Okay, I understand. That makes sense to me. Okay, dihedral angle. So that's the 2D version.
Yes.
It's a question from our live stream about Voronoi mesh. Are we getting 3D Voronoi meshes?
Not yet, but polyhedron is a requirement for that because the cells that you need for a Voronoi mesh needs to be a general polyhedron in general.
Makes sense.
So this is part of dealing with some of the requirements for that.
Okay. What is polygon angle? And how is it different from planar angle?
It is effectively a planar angle, but it's kind of important to
I mean, it's defined the interior, right? I mean, it's essentially the interior angle. From planar, it's not that obvious, but it's a planar angle.
So wait a minute. If I say polygon angle of regular polygon of 7, for example, okay, cool. And then if I say random polygon,
Probably.
okay, that's cool. So if I were to say angle path, of course I won't get the same results, but yeah, cool. Okay, that's cool. And what happens if you have a line with a bunch of joints in it? Does planar angle or polygon angle give something for that? If I have a polyline,
I don't think we have anything defined for that.
seems like it might be useful. I mean, so what
we need to think a little bit about. So that can be only for the interior points, first of all, because it may not be closed.
Well, what doesn't it just have a rule, a left or right-hand rule or something for which side of the angle path? In other words, if the angle path is coming from, if you assume it goes in a particular order, yes, there is always which angle the turtle turns through, which is what angle path is using.
Right. The angle path uses relative. That's what makes it easy, because you move to and you have a new state and then you turn from that.
Exactly. Right. But so I'm saying if you have a polyline, that's effectively defining a state because you have the sequence of segments in a particular order.
Right. And so the turn angle is well defined unless you sort of assume some default when you start.
Yeah, exactly. Which angle path I think has some way of doing, certainly in 3D, it has a way of doing that. Anyway, I'm just asking, so in planar angle, if I were to have 3D points, what does planar angle do?
In principle, if they are planar, we should return you the angle. But currently, I think we just support 2D.
Okay. All right. So that's another issue. Okay. So let me understand. Why is this called polygon angle? Because it's the angles in a polygon.
Yes. It's a standard concept in computational geometry that you get the angles in the polygon.
What on earth is a polyhedron angle?
Okay, there can be two interpretations of what that is. One is the dihedral angles and one is the vertex angles. The vertex angles are obviously solid angles.
Okay, so if I say here, dihedral angle of this thing.
Right. No, dihedral angle is kind of like planar angle. It's not defined for an object.
Okay, so if I say polyhedron angle.
So you need to give the point, which gives you the solid angle, or the edge, which gives you the
But wait a
angle.
minute, polygon angle seems to be perfectly happy to take all points as a one argument form.
Yes.
But here we have the point and the edge, so we didn't really want to make a choice or return the whole full list. We can, but it's...
Well, it seems useful to do that, given that polygon angle does that. I mean, because otherwise polygon angle... Okay, let me ask a naive question. Okay, so, index. How does it know whether you're giving it an index or a vertex point P or an index I? So you're saying that if I give this, is there an index number 5 or something here? Oh my God.
It's coming from the canonicalization. So the canonicalization, the vertices are sorted, kind of like in the graphic complex.
No, I understand. What the heck is that thing?
No, it's a complicated formula. You have exact numbers in there, right? Oh no, yeah, there are exact numbers all the way. So
yeah, those things you're confused by those algebraic numbers there.
Right.
Okay. Well, that's cool. Okay, I understand what this is doing now. So, okay. This form here, I don't think is going to be picked up correctly by the syntax highlighter. Are you sure it's working correctly? That it knows that that's a 3-argument form?
I will
I
check.
don't think it will. I don't think it will. I think it's also somewhat confusing for the users. I think it'd be better if you said poly, comma, PT or something, comma spec. I think that'll be clearer what's going on.
Okay.
What does full exterior mean?
Well, the exterior it's the full exterior. That's the complete 2 pi minus the interior angle.
Okay. Okay. All right. So let me understand dihedral angle and solid angle.
So look at the exterior. It's more what you would have in the turtle case.
Yes. Yes, I understand. So why is the dihedral angle not supported? Oh, I see. That's the analog of a planar angle. I get it. Okay, I get it. Okay, solid angle. The points spanned by those vectors. So if I say, for example, solid angle.
This is the way it's written there. It's fairly general.
So if I say 0, 0, 0, and then I say sphere points, I should get about 4 pi. Okay, now I'm confused.
Sphere point
20. So you're asking for some kind of 20-dimensional.
No, but look. If I do that, if I say graphics 3D, or
No. Those are rays. Those are vectors. And they define a conic hull.
Right, and that's actually that's one part we actually need to. We haven't really enforced it here because, yeah, like you said, actually the projection of those rays on the sphere should, define an actual polygon, a spherical polygon.
No, but I don't understand.
Okay, Stephen, look at the illustration, the 3D illustration there, where you have U1, U2, and U3 as the vectors.
Yes.
Okay. So those point, those.
No, I don't understand why this isn't making it. I don't understand why this doesn't do it. Because here, if I've got sphere points, let's say I've got 5 sphere points here. Those are points on the unit sphere, right? Which are vectors. Get what I'm saying?
Well, but you have to define a geometric region, right? Because the solid angle is, roughly speaking, the surface area defined by,
I understand. But so if I were to do that, how would I make a bounding polygon? How would I make, from those points, I want to see the 3D polygon. I just say that, right? I would just say graphics 3D of polygon of those points.
But it's
But it's a non-planar polygon, obviously.
Right.
Now, what happens if I say canonical polygon of that? So if I say, how does it remove the non-planarities?
No.
No.
Perhaps it should. How would it? How can it do that?
Well, I mean, with some triangulation.
There's nothing. No, it's very arbitrary. It's undescribable, largely.
Okay. But so polygon decomposition does not do this either.
No.
Okay, but I don't understand why my thing didn't work here.
Well,
those are perfectly reasonable points.
Yes, we can make it work, but what we need to do, what we really need is that region on the sphere. But those points don't uniquely define a region on the sphere.
Well, how do any of these points? I mean, spanned by. So you're saying if I have 3 vectors, it would. Is that correct?
Yes.
Right. Like if you take a cone, a tetrahedron.
Okay, so if I say solid angle 0, 0, 0, take %53, 3.
What? What are those 3 points? Are those the ones we're looking at there?
Yeah. Well, let's try.
That looks a little. That -1 and 1. I wonder what the hell that is.
Well, maybe we just have a bug we need to. Right, when they are, they may be collinear or such a thing where they don't define the stuff, so we get a singularity.
Yeah, well, here you've got -1 and 1, so those are antipodal points.
Right.
Right.
So something has gone wrong in that case. But you should.
I don't think it's wrong. It's just that the error message is not very helpful.
Yes, I mean,
those are 2 antipodal points on the sphere, and then a third point. And your claim is that doesn't define a.
I'm not entirely sure, Stephen.
Yeah, okay. That should define a triangle.
I mean, it defined, but we during the computation of the arctan, we should actually recover from there and just have 2 pi probably. Right.
Yes. Okay. Cool. Okay. All right, so that's angles. What else should we be looking at here? Okay.
Surface area requested by you.
Thank you.
There. A lot of other updates. Framework-wise, there's been a lot of work in internal frameworks to update the whole system.
What does this mean? It will give undefined when the thing doesn't match. So if I say area of ball, is that really what we want, as opposed to saying missing or something like that?
Well, it's not missing, but okay, so region measure, okay, will give you exactly what you expect. So area would be infinity for ball, obviously.
Mm-hmm.
Okay, and so region measure, ball comma 2, which is what area is, a 2-dimensional measure.
Yeah, right.
Okay, that would be infinity.
I see, but we think this is better because that way people will go and figure out that it's surface area.
Yes.
Given that you're going to return undefined, should you not return a message in this case?
We could.
I think you should, because that way, it basically points people to surface area. I think that's right. Okay. Sandra on our live stream, by the way, points out that the thing that case that we were looking at was a line on the sphere, so it should have 0 solid angle.
I see. Well, that's what I suspected, but I needed to sort of check it.
Right. There. Okay. Anything else we should look at for these?
No, I think that sort of covers it.
Yeah.
Okay.
Yeah, so all kinds of other improvements. Discretization now covers all primitives, including tubes and other things, splines.
That's cool.
And also mesh and boundary mesh region are graphic primitive now. So.
What
does that mean? So that means they can just be directly put into graphics?
Before they could be used in show, but now they can also be used in graphics 3D.
Okay, we have a question from the live stream. We're finally getting export to POV-Ray for polyhedral triangulations and other graphics primitives.
Not in 12.
What's involved in doing that?
A project.
It's just, but is it fundamentally difficult given what we have, or is it?
I don't think so. We just need to look at it. What we did a major update for anything related to polyhedral formats when we did a 3D printing project. So that was a major step up there. But there are other framework things that also kind of need to improve. But POV-Ray wasn't, is irrelevant for 3D printing. So it wasn't done at that time.
Okay, fair enough. Well, a lot of wonderful stuff here. Okay, I think that's it for this. It looks great. Looks really great. Don't forget those little utility functions for things like counting the number of faces on a polyhedron, though. And also, I think that there is some issue with the integration with polyhedron data, which would be good to look at. And I think you should consider having polyhedron of string dodecahedron work. Although maybe that's crazy. That may be crazy.
We did one sub-collection that is well characterized. We felt that we needed better parametric constructors, easy ones. That's why we are doing uniform polyhedron. And we will do those updates to polyhedron data so that better integrates with all this as well. But I suspect that there are more of these parametric constructors we want in the future. So I don't think it's the end of it.
Okay, questions also on the live stream about export to SVG or D3.
Okay, so SVG is one that hasn't been touched for a while, and it's more of an internal kind of issue where that project lands. D3, I don't think we've ever had as an actual format, but it might be interesting to actually support.
Yes, we've been discussing that with respect to the cloud. So I think there has been some work done there.
I see.
Hey, listen, it really worries me, this thing about holy polyhedra in the cloud. We really should make sure there's no horror there.
Right. So one thing that we focused on is to get the front-end project done, because they're going to rely on that for the cloud. So if that wasn't done, it would have been...
Yeah, I understand, but I don't know what's involved in porting that and whether they know that they know to port it.
You're right.
I will follow up. I will resolve that today.
Please.
For sure.
Yeah. Okay. Sounds good. All right. So I think, Roger, you and I are on again
Yes.
Immediately about numerics. And for those on the live stream, I encourage you.
For those on the live stream, that's optimization. I think a lot of you guys are interested in high performance, scalable optimization, and that's what it's about, mostly.
All right. So I'll see you there in a couple of minutes. Thanks. Good stuff. See ya.